So inheritance brings a pretty interesting set of features which are called collectively dynamic polymorphism. So what is polymorphism? Using something in multiple ways. Generally, it means that the same line of code could do different things in different contexts. We could start overloading operators for our objects, and we'll have a separate series of lectures talking about operator overloading. We've seen some examples of operator overloading already in our prior examples. We'll have also seen templates. So templates, both operator overloading as an example and templates, both are examples of compile time polymorphism, because everything is instantiated at compile time, and by the time the executable image of your program is generated, everything, all the decisions pretty much already are in place. Now, with dynamic polymorphism, what happens is that the program has the code to decide which function to call at a specific time, depending what kind of object the program is dealing with. So it only works through pointers or references. So basically, it's only at the time when you indirectly refer to objects. So of course, we'll make plenty of examples. And we have to use the inheritance features. In other words, we have to have a base class and we have to have derived classes in order to utilize the set of features called the dynamic polymorphism. So the idea behind this is that we're going to be learning how to redirect calls to appropriate functions at any given time. So instead of just reading these rules for you, let's start, or rather continue to explore this set of functionality using our examples with a customer set of objects. So I've created a new header file which I called customers. Okay, so this is an empty file, and I will now just show it side by side. And of course, since this is a new header file, I'll just copy my path to this file, add a comment right here, which I normally start in my header files, and now I can add the header guard. If not defined, this macro that I'm going to construct just about now, just use underscore included like this, and Shift Control U selects the entire word, and you can make it uppercase, and then define this macro, right? And then of course it needs to have an end if, and under end if we conclude this header guard, so that everything now goes inside the preprocessor conditional compilation. Okay, and so let's take our customer definitions like company, person, all of these definitions. Let's take them and put them inside this header file. Now, the assignment operators, we try to demonstrate the behavior of them, the chaining of assignments. So I'm actually going to remove them from this file and keep it pretty tidy, just like this. So I can have customers, and the customers will be the base class. You can see that the customer can be a company or a person. So these are the current settings that we have right here. So let's so we're now constructing some of these customers. We're able to establish customer, company, and the second company. Let's also try to create a person. Okay, so very similar to what we have done earlier. This assignment, I'll remove this statement. Let's create a person, right? Person, and I give those names to my objects. So here a person also can be initialized with phone and address. Okay, and we can use first customer that we have if we would like, instead of hard coding something. And then we also need to add the first name, right? So we need to add the first name. So this will be something, right? So I'll just hard code something, Joe, and the last name, company last name, like this. Okay, so we'll make it something for the sake of demonstration, Joe Doe. Okay, so we create a person, and of course here I am trying to configure my person object with some data populated like this. Okay, so here we go. We have some customers created, so we don't have any restriction here. We just create all these objects, and then we're creating couple of company customers and a person. And then what if we decided that we would like to print information from these structures? In other words, we would like to have a public function, just a very simple function, print. Okay, so we'd like to be able to print. Very likely it's a constant function, right? So it doesn't change anything inside the object. So this is the idea of the function. I can just probably write everything in this file like this, just in line, perhaps define this function. And of course, if I include input output stream, I can just use a standard cout, right, to print basically to print the name of the structure. Let's just print customer, and followed by the phone number, right? We'll just print the phone number, and then comma, and print the address, right? So we can just print the address right here. Okay. And to keep things as simple as possible, I'll just add formatting, the new line at the end of this output. So of course I can also add print to a company as well, right? So here very likely that I would like to print the customer information first. All right, so I'll print I'll call this function in the base class. So the base class function print can be accessed by saying print, and this is how you call this function. Okay, so I would like to say that the company will invoke print in the base class. So we still want to print the customer portion in part of printing information about the company. Okay, so this is company like this. Okay, and now we can print the name of the company, and we can also print the registration number. There's something simple. Okay, and then of course we can do a very similar output print in a person structure. So here we'll just say that this is a person, and print the first name, okay, and the last name. So we have this this plan to customize printing for individual customers in the system. So everything is in place. So we have this 3 versions of our print function. So now it would be nice if we could keep all of our objects that we create, if we could store them someplace in a vector, for example, in some sort of array or a vector. So what we could do is include a vector right here. Say, okay, let's have a vector, and then what we can add to this, can say, let's have vector of a customer, for instance, right? So we can have a vector of customers. Okay, and we can name it vect customers, something like this, so we recognize this name easily. Okay, and this is standard library vector, and of course we could populate it with these two customers. Okay, however, let's just say that we really don't want to print customer base. This is really the base class. We want to print these companies and persons. So it would be nice to be able to populate this vector with, you know, either doing it like this, push back, and add to this vector, for instance, company. Okay, add the company, add company 2. Oh, I guess I would have to use pushback 3 times, right? So pushback 3 times. Company 2, and a person. Okay, so we have these objects. Let's push them into a vector. And then we can have a pretty simple loop where we can say for, right? For each customer, right? For each customer, like this, inside this vector, in vector of customers. I just want to loop through the entire set of all sorts of customers. And for each customer, we're going to call customer print. Okay, so something like this. So this is an idea. Create objects, 1, 2, 3. We do create some of the base objects at the top of our program right here, so we can clean it up like this. But I'm not very interested in storing in my vector these two. Instead, I use them to populate the information for the company, company 2, and person. Okay, so let's give this a try. I save everything and then build, attempt to build this. And I get some errors. Let's take a look at what kind of errors I'm getting here. Customer undeclared identifier. Oh, of course, I need to include this file. Okay, so normally you place standard library includes at the top of the file, and then your own includes. And of course, your own includes are using quotes. So we're just going to say build this. Okay, so this builds fine. So let's see what happens when we start printing. And notice that we were successfully creating companies and persons. And now I'm going to press Ctrl F5 to make it run, so it runs. And let me see. So it printed. Yeah, so this output is unhappy because I made a mistake of, instead of updating company 2, I updated company. So this needs to be changed like this. And let's try this again. It was a little problem, so we're just going to rebuild and rerun this. And so here we're printing, let's just create customer 3, I think, to properly initialize a person. Okay, so we have a person, so let's give them all unique values here. So it will be like 555, 444, 2211, something like this. Okay, and also change the address to 1 South Street. How about this? Okay, and then use this customer 3 to initialize the person. Okay, so use customer 3 for the person, because it'd be nice just for the sake of debugging to recognize the differences. Let's run this again. Okay, so conversion here. Yeah, so the number is a little bit too big for this, so we'll just drop the area code down to 1. Okay. All right. Okay, so this is fine. So now observe that, of course, when we were constructing our vector, we populated it with a couple of instances of the company and one instance of the person. And yet, when we run the code, what we get in the output only the information about the customer.